All right, so how do we determine which angles are going to give us a value of sine equals 1/2? The key to these questions is first off to recognize that there's two possible answers as long as we're talking about 0 to 360 degrees. So I'm going to start off by drawing a little picture. Now, based on everything that we know, sine is always based on the y value. So if I look at the value here, we have 1/2, which means sine has to be positive. So there's two possibilities in terms of our answers. So I'm going to draw the first triangle in the first quadrant, because no matter what angle I have in the first quadrant, sine is always positive, and a second value in the second triangle. So if you'll notice, sine is defined as opposite over hypotenuse. So that means I have 1 and 2. Here I'm going to have 1 and 2 as well. So as you can tell, we don't know which one is which. And in this case, we won't know. We have to come up with both answers. If you'll notice, these sides represent the 30, 60, 90 triangle. So I'm going to add in that other value. So ultimately what I'm looking for is my acute value right here. So across from the 1 in that 30, 60, 90 triangle is always the smallest angle, which is 30 degrees. Now you can do it that way, remembering, or if you use your calculator, you can do theta equals sine inverse of 1/2. Your calculator is going to give you an answer of 30 degrees. But that's not your only answer. So that's the first answer we have, but there's a second one. We know that second angle has to be in that second quadrant, and in order to get that, we're going to do 180 minus 30, because we haven't quite gone all the way around. So we end up with theta 2 equals 150 degrees. So that's how you can use your related acute angle to come up with the appropriate angles that are possible. Using the same type of reasoning, so cosine is negative whenever x is negative. So that means the cosine possibilities are in the second quadrant and the third quadrant. Cosine's a bit trickier with your calculator, because if you were to do this on your calculator right now, it's not going to give you the acute angle. It's going to tell you what the value of the actual principal angle is going to be, and then you have to do a little bit more work to translate it. That's why using your triangles is super important. So as I was talking, I added in the ratios. Cosine is defined as the adjacent. So that's going to be the x-axis over the hypotenuse, which is 2. So once again, I have that 30, 60, 90 triangle. And it turns out that always across from the 1 is the 30 degrees once again. So in order to translate that into my answer, 30 is not actually one of these answers, because 30 would be in the first quadrant. So from my picture, I know that theta is going to equal 180 minus 30, which is 150 degrees. And then the second value that we can end up with is, instead of subtracting that 30, we're going to add it. So the two values for this here are 150 and 210. You can always check this on your calculator. If you do the cosine of 150, it's going to give you negative 0.866 with lots more decimals afterwards, but this is the exact value. Okay, so the last two examples that we're going to look at, we have cos of theta is equal to 1. Now this one is a little bit different because it's not an actual ratio. It is 1/1, but your answer isn't actually in any quadrant. It's on the axes. So if you take your calculator and do the inverse, your calculator is going to tell you that your answer is 0 degrees. So in this coordinate plane that I've drawn here, 0 degrees is right here. But we're dealing with 0 to 360. So I can rotate all the way around and end up with a second example. So theta of cos, in this case, has to be 0 and 360 degrees. If we were to say cos of theta equals -1, the only value that would work in that case would be 180. Now likewise, sine has a value of 1 at the 90-degree mark and then -1 at the 270-degree mark. So anytime you have 1 or 0, those values, you're actually on the axes. Now the last one that we're going to look at is the sine of -√2 sine theta equals negative 1 over root 2. Sine is negative when y is negative. So in quadrant 3 and 4, we have our answers. So sine is negative 1 as your opposite, root 2, negative 1, root 2. And then that means this here is also going to be 1. So this is our 45, 45, 90 triangle. So now when I come up with my answers, theta 1 is going to be 180 plus 45, which is going to equal 225 degrees. And then theta 2, same process, but you'll notice it's in the fourth quadrant. So anytime we're in the fourth quadrant, it's going to be 360 minus the related acute, which equals 315 degrees. So as you remember, your acute angle's in the quadrant 1. To find that principal angle in the second quadrant, it's 180 minus theta. Over here, it's going to be 180 plus theta. And here we have 360 minus theta. So that setup will always work. So anytime you're looking for two possible angles, first off, you need to identify which quadrants your answer are in, and then you can use a combination of your special triangles and working with your calculator values. Hopefully this makes sense, so you can go ahead and try the assignment now.